so we had we had these saturated fats, which no double bonds. Then we have our unsaturated, which have at least one double bond. Yeah. That's right. Let's see if I can finish it. I'm finishing up in the last few facts about fatty acids, then we'll start fats and heat. Yep. These are like the last 2 or 3 things about trans fats. They start off as unsaturated, and the goal is that they would be saturated, but they're not. They're still they have at least one double bond. So this is it. They are technically unsaturated because they have a double bond, but physically look like a saturated fat. That's where it's tricky. Your body's, right, because the saturated fats are all straight and stick-like, which is what trans fat looks like. But it has a double bond, so it's somewhere in between properties. So the hydrogenation reaction that we use to get from unsaturated to saturated, which sometimes ends up in getting caught in the trans fat stage. Alright, so let's say I just have a boring molecule like this. One carbon stuck to another carbon with a double bond in between the two of them. If I want to hydrogenate them, I'm going to use a ridiculous amount of hydrogen gas, high pressure. And the hydrogen gas is going to turn that double bond to a single bond and give both carbons an extra hydrogen. Not the reaction, but that you use hydrogen gas. Like, that's the interesting fact about it. Well, it was World War II-ish, and butter was an increasingly hard thing to find because of the rationing and whatnot. And so in France, they use a lot of butter in their cooking and their bread. And so the French government put out a call to find an artificial butter. They're like, we need butter because we're French. And so the government paid scientists to figure out how to make an artificial butter. And so this, right, is like a vegetable oil of sorts. And so they took vegetable oil, they hydrogenated it, and made a butter-like thing. They made margarine. So margarine is a hydrogenated oil of some sort. Of course, that's not cool to call it that. We call it margarine rather than chemically modified oil. That's what it is. Yeah.
They said that, like, when they did rationing in World War II, they would get margarine, like, cook everything.
Yep.
And they had, like, food coloring that you could dump into the margarine to make it look like butter.
Right, because by itself it's white, which is not visually appealing. So margarine is artificially colored yellow to make you think it's butter. Yeah, so when you're eating margarine, you are eating chemically modified oil, which as a sales pitch, right, doesn't work as well.
How come it's so bad for your body? Like,
That's my next point. No. Yeah. Yeah. It is in general. depends on what your current health state is. Right. I can't universally say butter's always better because maybe there's some reason that butter's not good for you. But can't go, right, don't, I had an uncle that just would eat sticks of butter apparently. Like he would just go to the fridge, unwrap it and eat it like a banana. Just.
I like cold butter like that. Like when I'll save it, I'll like sugar butter.
Alright, so let's see. Alright, so food manufacturers must label if they have trans fats in them. They're not going to call it that. They're going to call them partially hydrogenated. Partially hydrogenated oil, which means the same thing, right? If it was unsaturated and they hydrogenated it but didn't completely hydrogenate, right, it's going to be a trans fat, partially hydrogenated. When you're reading labels, thinking about trans fat, they're going to say partially hydrogenated. Now, the FDA only requires that they say 0 trans fat or trans fat free. It's less than half a gram per serving. So trans fat free / 0 trans fat does not mean 0. Just means less than half a gram per serving. So, trickiness with the labeling. And so maybe partially hydrogenated soybean oil, cotton oil, whatever. It'll say partially hydrogenated in some manner or whatnot. Now, not all trans fats are man-made. It does occur in nature sometimes. For instance, how many people have eaten a pomegranate lately? No. Pomegranate? Is that spelled right? No R? Pomegranate? I've never eaten one.
Never eaten a pomegranate?
It's not on my go-to fruit list. Alright, yeah. Typically it's apple, orange, pear, banana, right? Something I can carry in my bag. That's so much work. No. Just like star fruit, same thing. A lot of work to eat that. If it requires more than like biting into it, probably off my fruit list. Oranges barely make it. Mandarin oranges, because it comes in a can, I can pop that lid and just eat it. So, peaches, iffy. They're very sticky, and they drip a lot. And so it depends on where I'm going to be eating this fruit. Because if I'm going to be eating it in my office, it's going to be a disaster. It's going to be sticky everywhere, and then my keyboard is sticky, and then I get angry. And so I try to stick to fruits with, I really hate stickiness. Really, really hate being sticky. Like, it's my number one pet peeve. I could roll around mud, and that'd be okay. But if I roll around like honey or something, oh, angry, like Hulk angry. Makes me so instantly angry. I'm sure everyone has something that makes you instantly angry. As soon as that happens, you're like, I'm so upset right now. So the pomegranate, back to my story. Pomegranates are low in fat, but the fat that they do have is about 70% trans fat. So right, it is technically a low-fat fruit, but most of the fat that it contains is this trans fat form. Your body doesn't know if it's natural or not. Your body's not checking the source. So your body's going to process it like it would eating margarine. So, man, I wrote really big. All right, let me finish my thoughts over here. Alright, so in terms of heart health, how trans fats make a difference? So trans fats raise your LDL cholesterol, which is the artery clogging kind of cholesterol. Because there's actually two types of cholesterol, and one's a good kind and one's a bad kind. And this is the low density lipid cholesterol, which is the bad kind. It causes like arteries to clog up and whatnot. So trans fats raise LDL cholesterol a little bit. So it's not terrible. Saturated fats raise it the most. It's not that it can't process it, it does process it, but it turns it into these guys. And so your body's processing things all the time. It's just sometimes, like unsaturated fat, your body can't process it, so you poop it out. LDLs are made by your body. Yeah, cholesterol, when you're pooping, that's fat and solids going out. When you're peeing, that's your liquids going out. We'll talk more about that later, colon health. All kinds of fascinating facts. We talked about vitamins, water-soluble vitamins versus fat-soluble vitamins. The fat-soluble vitamins you can actually overdose on because they build up in your colon. Or a water-soluble like vitamin C, you could take 1,000% vitamin C. Your body's going to use 100 and pee out 900%. So you can't overdose on a water-soluble vitamin. We'll talk more about that later. You can overdose on vitamin K. Like that. Yeah.
I always been told for trans fats what it does when you take a lot of trans fats, you still really the obesity. Does that actually increase it or
I guess I don't have any scientific evidence to say that's true or not.
okay.
Yeah, because like the things that, it could just be the type of foods that typically have trans fats. The trans fats are typically found in like fried donuts or french fries or anything else you deep fry. That oil, unless they're a company that has changed their type of cooking oil. I know some companies have switched to, like Chick-fil-A is only peanut oil, which is fully unsaturated. A lot of companies like to use the trans fat oil because it fried at a really high temperature without getting all smoky. Yeah. Yeah, McDonald's fries have changed somewhat because they switched to oils that they deep fry in. Or, like, same thing like chips, depending on what brand they are. So it probably is more just a type of food, because you could eat your body weight in french fries and still feel hungry like an hour later. Or I can. I guess I don't know if that's true for everybody. I feel like I could eat a never-ending supply of McDonald's french fries and never really be full. But, Alright, any questions about trans fats, saturated fats, fats, and fats?
So we just actually have these really fat
Yeah, so we'll talk more in another chapter about what your body does with fat. But in general, your body can make cholesterol, and it does that through eating fat. And there's reasons your body needs cholesterol, like your cell membranes. If you're thinking about your biology cells, they have to have cholesterol in it in order to be functional. You definitely need some cholesterol in your cells, which means you have to eat some fat in your diet. But if you start eating too much fat or the wrong kinds of fats, your body does odd things with it. Alright, let's talk about cooking with fat, so fats and heat. Alright, so in general, fats in general don't have a sharp melting point. So when you're thinking about something melting like an ice cube, right, it stays as a cube for quite a long time, and then when it starts to melt, it goes really quickly. So we have fairly sharp melting point. But fats don't have that. They don't change from a solid to a liquid very quickly, which is why if you're thinking about your butter, like cold butter becomes like kind of soft butter, becomes like softer butter, becomes like spreadable butter, and then eventually will turn into a liquid. There's a lot of little steps in between. They melt over a large temperature range. But you can eventually turn your liquid fat into a gaseous fat. That is possible. Somewhere between 260 and 400 degrees Celsius. Depends on the type of fat we're talking about. So it's going to depend on the length of the chain and if it's saturated, unsaturated, or somewhere in between. So the point at which a liquid fat becomes a gaseous fat is called the smoke point. I don't know, gas fat sounds like a terrible phrase. But rewrite that to be a less offensive sentence. But the temperature at which your liquid fat becomes gaseous state fat, fats in the gaseous state, it's called the smoke point. Let's see, and this temperature, the temperature at which the smoke point occurs, depends on the initial free fatty acid content. So we talked about most of the fatty acids being caught up with the glycerol. It's going to triglycerize. Not all the fatty acids in your butter or whatnot will be held together in a triglyceride. Some of them will just be free floating, hanging out by themselves. If you have a lower amount of free fatty acids, that tends to be more stable. Which means you have to put more energy in to get it to turn into a gas, so a higher smoke point. So if we're going to compare two big categories of fats, let me finish my thoughts down here, then we'll come back to emulsifiers. The free fatty acid levels in oils are lower than in animal fats. So if you're thinking about it, right, if you put something on the grill, if you put your steak on the grill, you can start to see that when it drips into the coals or the flames or whatnot, right, all of a sudden it like smokes up fairly strongly. Animal fats have more free fatty acids and typically have a smoke point around 190 degrees Celsius. So which is why your burgers and your steaks and whatnot produce a lot of smoke, because the fat dripping off them into your grill's going to be hotter than 190, so that fat is going to turn into kind of like a fat plume. A gaseous amount of fat floating around in there. Which is why the underside of your grill is probably greasy, because all that smoke, not smoke, grease fat, in its gaseous state, hits the inside of your grill and then solidifies again. Yeah, if you're grilling with the lid open, yeah, you are then breathing in gas fat. You also smell delicious. Yeah. The gas is not carcinogenic. There is some information out there that's like, maybe not, yeah, about whether or not when you grill something, you get those grill marks, those burnt spots. Are the burnt spots actually carcinogenic? Like, because you cook the meat past done, right? You pushed it all the way to burnt. The question is, eating a lot of burnt food, does that have a detrimental effect on your health? There hasn't been a large enough study to know if that's true or not. So, yeah, last thing. So these oils are closer to like 230. So the smoke point of oils more like 230, which is why it takes a lot more energy to get. So if you think about a grease fire, it's typically not that you have your sunflower or vegetable oil in the pan. It's usually you're cooking some sort of meat product that has made a pool of fat it's sitting in, and it gets past 190 and catches fire, starts to give off gas. Now obviously if you're deep frying something, that's different, that's much hotter. But you guys can all be careful when you're cooking this weekend. Questions about heating with fat? Except that, look at this when you're using a vegetable oil. You can go up to 230 degrees Celsius. Where does water boil on my Celsius scale? 100, right? So if I'm going to cook something in boiling water, I can't get it any hotter than 100. If I'm going to cook something with oil, I can get the temperature all the way up to 230 before it changes state. We often cook things in oil because it's much hotter, which means it cooks faster. Besides the fact you get the olfactor, because the outside cooks really, really fast. And then the inside cooks a little bit slower, which is why you have a french fry that's like really crispy on the outside and kind of soft on the inside. Cooking so quickly. Same thing when you're sauteing something in oil. You'll get kind of a crispy outside and the inside's kind of soft. The speed at which it's able to cook it. Alright, let's talk about a controversial food, mayonnaise. You are either on one side or the other about mayonnaise. Not many people are in it. Okay. Alright, that's combined with other ingredients, which are called emulsifiers. Produce a creamy texture to the fat. Now, if we're thinking about a common thing, so I'm thinking about vegetable oil and water. Do those combine? No, right? They definitely make separate layers. If, however, you include an emulsifier, it will force them to stay together. Oil, otherwise known as my fat, don't mix. But emulsifier prevents them from separating. If I had a tube, which this will be your lab 2 weeks, we're going to make our own. Not really mayonnaise. but we're going to do some emulsification. So you're going to have a tube, and you're going to put half full of oil, half full of water. And we're going to add different emulsifiers to see how well it can force the water together. So one of the most common emulsifiers okay, there we go. Emulsifier is egg yolk, our egg yolk, which is what mayonnaise uses. Mayonnaise uses a variety of types of oils, depending on what kind of mayonnaise you want to make, but typically a vegetable oil with water and raw egg yolk, pasteurized raw egg yolk. Used to be just regular egg yolk, but then salmonella concerns, whatnot. Now it's pasteurized egg yolk mixed with oil and water makes mayonnaise. Let's see. Now what makes egg yolks interesting is that they are diglycerides. Everything we've talked about so far have been triglycerides, right? 3 fats with 1 backbone. These are diglycerides, so they have a glycerol, but just 2 fats hanging off of it. So it's going to be something like that. Where 2 and 3 prong are fatty acids, and the third one's just an OH. This OH is polar. These 2 guys are nonpolar. And so this diglyceride has properties of both. It's both polar and nonpolar. So the nonpolar can grab onto the oil. The polar can grab onto the water and hook elbows with both and prevent them from leaving. They grab both sides of it. And the diglyceride that kind of looks like this, if it had actual chemistry in it, not just the fatty acid, the one found in egg yolks is called lectin, which you can buy by itself, which will be one of the choices we have when we make our own emulsions in 2 weeks. We're going to try egg yolk, we're going to try lectin, and another one called zinc gum, which is a natural emulsifier also. A few other alternatives to see which is the best molecule to hold oil and fat together. Then sure. Plus, we'll try a type of fat, see which fat works best together. And then you guys will have the ability to make your own. When you go home Thanksgiving break and you make all those turkey sandwiches, you be like, let me whip you up some fresh mayonnaise. Eat it. No. Okay. Just give me an answer. No. Yeah, Amy.
Like other.
It is in a lot of, it's in a lot of things.
Common, that have.
It could. They are allergic to eggs. It's often this protein, diglyceride thing that people are allergic to, which is why when you're reading the back of the box of the container, you kind of have to look, because it may not list eggs, but it may list lectin, because you can make the lectin without using an egg. I can whip some up in my lab if I needed to, egg-free, and then add it into food. Yeah, when you read labels, a lot of the stuff at the end is just stuff they make in a lab, and they just add it in.
My best friend just had like a really ridiculous diabetes type stuff. And her like all this stuff she has to cut out, and so that was one of them. She's like, I can't do this because that is so high.
It's in a lot of stuff, yeah, because a lot of foods, in order to be shelf stable, use something like this to keep the oil from kind of seeping out of the food. So it's a tricky thing, because you want your food to look as good 6 months from now as it does today. So if you really had an actual cookie that you made today, and you wait 6 months to eat it, even if it's in the fancy sealing package, it may not be the same. So they have to add some stuff to it, extra oil, some of these things, try and keep it looking good.
Peanut butter, like if you get normal peanut butter, that gets watery, but if you get organic, like it's like
Yeah, that's the oil. Yeah. Yeah. So peanut, if it's no stir natural, it means it has some molecule like this that's keeping the oil from leaving the peanut butter. But if you get the organic peanut butter, over time the peanut oil will float to the top and leave behind like the solid peanuts and the watery portion of it. So it's going to use something like this to kind of keep the oil from escaping. Yeah. So it's not a scary molecule, right? It's technically natural from egg yolks. We just don't get it from all the egg yolks. I can make it myself. That's the other thing. Talk earlier about what it means to be organic. That's tricky. Technically, this molecule is organic, found in nature, still considered organic. According to the FDA, the answer is yes. But according to you, maybe not. How are we feeling about fast? Fast? All right. Let's try a new food category then. What's my next thing? Carbohydrates. My sheets are all out of order now. I think that's right. All right. Carbohydrates made of carbon, hydrogen, and oxygen. Some of the three best atoms out there. Alright. Sugar is the simplest of all carbohydrates. Comes either as 5 carbons or 6 carbons. If it's 5 carbons, it's called ribose. And ribose is super critical to you guys because that's the sugar that's found in DNA and RNA. DNA and RNA only exist if you have ribose in your system. Yeah.
How would you use any sugar at all or anything that like DNA breaks down?
No, that's a good question. So you have to have sugar in your diet in some form. Your brain can only transport glucose across the blood-brain barrier. That's the only form of energy it has. So if you are on a super, super low carbohydrate diet, your brain's starving. There may be reasons for you to be on a super, super low Atkins-style diet, but your brain needs sugar to operate, and your body literally runs on glucose. That's where all the energy comes from, and that's where all of the intermediate chemicals are needed to do any other process. So without some amount of sugar in your diet, your body's going to be running real ragged. So the DNA won't break down if you don't have a lot of sugar, but you're not providing it any new sugar to do anything, right? So when you have a cell, your cell eventually kind of dies, or it does the whole mitosis, meiosis thing, right? Which splits apart into two things. Well, then you have to make double the DNA. If you have no sugar in your diet, it's hard for your cells to do that. There are ways around it. Your body can turn fat into sugar. That's really labor intensive for your body to do that. It would prefer just to have the raw material and go straight to making DNA. Okay, 6 carbons. These are the ones you're probably familiar with. Glucose, fructose. Talk about those guys a little bit later. Glucose, fructose. But those are the 2 common 6-carbon sugars. Your body has to have glucose to do just about everything. And it can, if it only has fructose, it can make do. It needs to have one of those 2 of those. carbohydrates are used for the purpose of storing energy. In providing starting materials. For other, we're going to call them chemical reactions, but they're chemical reactions for your body to make stuff. So in general, they're chemical reactions, but they're chemical reactions to make proteins, or chemical reactions to make DNA. So it's not generic carbon things. Carbohydrates can also be used as structural material, like cellulose or pectin. Some of those molecules are technically sugars. Cellulose is easier one to think about. Cellulose, right? That's the thing that plants need in order to make a leaf. That's technically a sugar, but the sugar arranged in such a way that it's very stiff, whereas these guys up here are pretty floppy. I think I've reached your guys' limit of information. Yeah, Corey.
Okay.
Yeah.
Sauerkraut is good.
Mhm.
Fat-free food. Full of